Hello everyone. Since this is the week of Thanksgiving, there's not going to be a virtual lesson this week, so I wanted to make a short video to show you some examples of 4.04 trig functions of any angles. So this will be a little bit shorter than the normal virtual lessons, and it's just meant to give you some examples that are similar to the homework problems so that as you go through them, you'll know how to do examples. So let's get started. For the first example, it's going to be very similar to the last lesson, so this isn't going to be anything new to you if you watched the last video. Find the value of cosecant theta of an angle theta in standard position if you know a point on the terminal side is 6, 5. So we just have to find the cosecant. I don't have to find the other trig functions, so I'm not going to worry about them. So to do a problem like this, if they give you a value on the terminal side, you plot that point. So it's going to be a quadrant 1 angle because it's over +6 up +5, right? So it'd be in quadrant 1. And then you'd sketch the angle from the origin, and you would drop down to the x-axis. Now you're going to label the sides of the triangle. Over 6, so 6 would go down here, up 5, 5 would go up here. Because it's in quadrant 1, both values are positive. If it were in a different quadrant, I might have some negative values as well. But no matter what, the hypotenuse is always positive. So now we're going to use Pythagorean theorem to solve for the hypotenuse. So we're going to do a squared plus b squared equals c squared. 36 plus 25, let's see what that is, 61. So the hypotenuse, c, if I take the square root of both sides, is root 61. And we'll leave it like that. I don't think it can be reduced. I don't think any perfect squares go into 61, so I think we're good. So it's root 61. Now remember, your reference angle, your theta, always connects to the x-axis, so I want to draw that in. Now they want me to find the cosecant of theta, so I know SOHCAHTOA, I know what sine, cosine, and tangent, I know what those ratios are, but I don't know the reciprocal ratios, but I can figure it out. I know that cosecant is the reciprocal of sine. So if sine is opposite over hypotenuse, I know that cosecant's got to be hypotenuse over opposite. So the cosecant of theta is going to be the hypotenuse over the opposite, or root 61 over 5. And that's my answer. So again, a review from the last lesson, except this time only finding one of the trig functions and not having all whole numbers. Alright, so let's keep going. So reference angles. What's a reference angle? When an angle's in standard position, its reference angle is the acute angle that is formed by the terminal side and the x-axis. The reference angle will always be positive, and it will always be less than 90 because it's acute. Let me show you some examples of reference angles. Here, you're not going to have problems like this in the homework, but I want to show you how to find the reference angle. You have to know how to do this to solve the problems in the homework. If you have a 100-degree angle, the first thing you would do is sketch it in standard position. So you'd put the first side here, and then this is 90 degrees, so 100 is going to be just slightly past 90. Okay, so that's what a 100-degree angle looks like. Reference angles are always acute and they always drop down to the x-axis. So your reference angle is going to be dropping this angle to the x-axis, and that angle theta is your reference angle. So what would your reference angle be in this case? Well, a straight line's 180 degrees. This angle here is 100, so your reference angle's got to be 180 minus 100. It's an 80-degree reference angle. Okay, let's do another. Negative 250 degrees. Sketch it in standard position. Standard position always starts here, and then this time you're just going to go in the opposite direction. So this would be 90 in the opposite direction. This would be 180 in the opposite direction. This would be 270. So 250 degrees will be just before this 270 degrees. So again, it's a quadrant 2 angle. To find the reference angle, drop it down to the x-axis. That's your reference angle. What would the reference angle be? Well, if this is 250, 80 plus 180 plus what is 250, and that's going to give us our reference angle. So 70 degrees. And let's do one more, 200 degrees, sketch it. So this would be 90, 180, so 200 degrees would be just a little bit past 180. To find the reference angle, drop it down to the x-axis, which in this case we're dropping up. So if that's 200 and that's 180, that would be a 20 degree reference angle. So we need to review again 45, 45, 90, and 30, 60, 90. In a 45, 45, 90 triangle, the sides are always in proportion to each other, 1, 1, root 2. So the side across from the 40 is always going to be 1. The 45, the side across from the 45 is going to be 1, and the side across from the 90 is root 2. So what that means is if I have a 45 degree angle, reference angle, I can fill in those ratios on my reference triangle. 1 across from the 45, this would also be 45, so another 1 across from there, and then a root 2 across from the 90. And then you can use those values to find the sine, cosine, tangent, or whatever trig function you need. If you have a 45 degree reference triangle in another quadrant, you do the same thing, except some of the values will become negative. So it's still going to be 1, 1, root 2 as your side lengths, but you go left 1, so this one would be negative. And then if you had a 45 degree reference angle in the fourth quadrant, you'd still have the 1, 1, root 2, but you would go right 1, down 1, so this one would be negative. And then for 30, 60, 90, the ratio is 1, root 3, and 2. So the 1 is always across from the 30, the root 3 is always across from the 60, and the 2 is always across from the 90. We talked about this in the last lesson. So if you have a 30 degree reference angle, but they don't give you the side lengths of the triangle, you know that across from the 30 is a 1, across from the 60 is a root 3, and across from the 90 is a 2. And you can use those values to find sine, cosine, tangent. If you have a 60 degree reference angle, same thing, except, let me draw this a little better. Same idea, except your 30 would be up here, so your 1 would be across from the 30, your root 3 across from the 60, and your 2 across from the 90. So when you're dealing with reference triangles, you might be given a point, like we were in example 1, but if you're not given a point, chances are it's a special right triangle, and you need to fill in the ratios yourself. So let's do some more practice where we sketch angles in standard position and then state the reference angle, and then finally state the point on the terminal side. You're going to have problems like this in the homework. So the first thing we have to do is sketch the angle. 7 pi over 6. You probably don't know where 7 pi over 6 is off the top of your head. But if we convert it to degrees, then you'll know exactly which quadrant it's in. So what I like to do first is convert to degrees. The pi's cancel, so 7 times 180 divided by 6. $210. So that tells me it's going to be a quadrant 3 angle. So if I sketch it in quadrant 3 and connect to the x-axis, I have to figure out my reference angle. It's going to be a special angle, either 30, 45, or 60. It has to be. If not, I'm not going to have any way to answer this question. So if this is 210 and this is 180, this has got to be a 30-degree reference angle. So let's fill in the ratio, and I'll write 1 root 3, 2 at the top. That's for 30, 60, 90. So 1 across from the 30, root 3 across from the 60, and 2 across from the 90. So the point on the terminal side would be over root 3 down 1. It's in quadrant 3, so it's left and down, so both those values are negative. So the point on the terminal side would be negative root 3, comma negative 1. And that would be your answer. Okay, why don't you try 6 and 7 on your own? You can pause it, try it, and press play when you're ready to see the answer. So convert to degrees, 3 times 180. Whoops. Divided by 4, 135 degrees. So that would be in quadrant 2. And your reference angle would be 45. So 1, 1, root 2. This one would be negative because it's left 1. So the point on the terminal side would be negative 1, comma 1. And the last example, 5 times 180 divided by 3, 300 degrees. Quadrant 4, this would be a 60-degree reference angle. And across from the 30s 1, across from the 60s root 3, but negative because it's down, it's quadrant 4 and 2. So your point on the terminal side would be over 1 down root 3. And that would be your answer. Okay, so I have 2 more minutes left in this recording before it turns off on me, so let me try to finish real quickly. The last example, find the point on the terminal side of pi over 4 that has an x-coordinate of 4. So sketch the angle. Pi over 4 is 45 degrees, and it's in quadrant 1. So sketch it. Now, if I fill in my ratios as 1, 1, root 2, that will give me an x-coordinate of 1. They want me to have an x-coordinate of 4. So I need to multiply everything by 4 to keep things in proportion. So 4 root 2, 4, and 4. So my answer is 4, comma 4. So for your ratios, they don't have to be 1, 1, root 2. They just have to be in proportion. If you multiply everything by the same number, that's okay. So to end this recording, here's the practice problem. Try this one, pause it, press play when you're ready. Find the point on the terminal side of 5 pi over 3. So let's sketch it. Where is 5 pi over 3? 300 degrees. We did that one already. So 300 degrees, it's in quadrant 4. It has a 60-degree reference angle. So fill in your ratios. 1, root 3, but negative, 2. And they want the x-coordinate to be negative root 3. Or actually, that should be y. So they want the y-coordinate to be negative root 3. Well, it already is, so you don't have to do any multiples. You don't have to multiply by anything like in the last example. So your answer is over 1 down root 3.